Before you delve into actually doing problems with negative exponents, there's three things I want you to keep in mind. The first is that an exponent tells you how many times you multiply something by itself. So when you see, for instance, a to the third, that exponent tells you to take that base, which is a, and multiply it by itself 3 times. So a times a times a. Two other things that you may not really think about is that negative symbol, this symbol, it actually means opposite. It doesn't mean negative. It's just the first time you ever see it in your life. We're using it to make numbers negative, but it means do the opposite thing. And then the last thing is that I know you know the opposite of multiplication is division, but another way to think of the opposite of multiplication is multiplying by a reciprocal. For example, if I asked you what the opposite of, say, 3 times 2 was, the opposite of that you would know is 3 divided by 2. That's like kind of what you learn in pre-algebra. But what's not as obvious is you could take 3 times 2 and the opposite of that could be 3 times a half. Both of these things are going to give you, the same answer of 1.5. So this seems a little weird, but there's a reason why I prefer for you to think about the opposite of multiplying being multiplication by a reciprocal. And again, if you haven't studied your 4th grade math in a long time and the word reciprocal, you're like, I know it, but I don't know if I know it. Reciprocal means flip something over. So if the reciprocal of 2 was for me to take that 2 and to flip it over. If I wanted the reciprocal of, say, a 7th, that guy's reciprocal would be flip that over, would be 7, And it will be most helpful if you think about this as a reciprocal as being as like, if it was on the bottom, it goes on the top. If it's on the top, it goes on the bottom. So let's look at the actual rule for negative exponents. So here are 2 examples I just conjured up. The first one says 5 times m to the negative 7. When you're dealing with a negative exponent, the first thing to keep in mind is what exactly is that exponent talking to? And the exponents always talk to what's directly beneath them. So in this example, this exponent is talking just to this m, not to the 5 at all. Based on the rules I kind of mentioned earlier, that negative exponent is going to mean to, instead of take m and multiply it by itself 7 times, do the opposite of that, which is to take the reciprocal of m, which basically means take this m and push it in the bottom of the fraction. Now you're saying, hey, there is no bottom to that fraction. But actually, I'm just going to go ahead and make one. So this 5 has no exponent on it at all. So it's going to stay where it is, which is technically there's like over 1 here. So this 5 is going to stay in the numerator. And then this m to the negative 7 is going to pop down to the bottom. And then that 7 is going to become a positive. And that's basically it. The rule is if you see a negative exponent, you're going to push it to the other side of the fraction bar and then change the sign. And that's basically the whole idea. For the second example down here, I have a negative exponent just on that n. So it has to change. We can't have negative exponents in our final answer. And so what will happen is this 3 is left alone where it is. This 2 doesn't have anything on it, stays where it is. And then I need to do the opposite of multiplying n by itself 2 times, which is to take the reciprocal, which is, like, since this is in the bottom, put it in the top. So the n pops to the top, and it becomes positive. So the short answer is, if it's got a negative exponent on it, you put it on the other side of the fraction bar, you change the sign, and you're done.